Hello, so we have learned how to find our percentage under the curve of a normally distributed problem, but now I want to talk about quantiles. So let's say that I told you that 95% of crab, the length of the legs of a crab, or the shell, 95% of them had a length of less than something, which means I don't know what that value is. I know the percentage, but I don't know what that number is going to be. So if you think about it on a bell-shaped curve, when I look at this, 95% are less than k. So if this is my mean, 95% is going to be right here that's less than it. So this whole shaded region, this is calculated by 95%. The problem is I don't know what this number is. So in all of the problems previously that we've been learning, we knew k, we knew this, and we were trying to find our percentage. But now I'm giving you the percentage, and I'm going to be asking you to find k. So we're going to be doing essentially the inverse, and that inverse is called your quantile. So your quantile is that k, and in this case it's the 95th percent quantile. So finding the quantiles is just doing the inverse. So we need to do the inverse normal function, and so on our calculator, we're going to use our graphing calculator to do this. So we're going to go second vars. Last time we used number 2, which was normal CDF, but now we have to use number 3. So how do you know when to use what? Well, if you're trying to find a percentage, you're going to use number 2, which is your normal CDF. If you're trying to find the k value, you're going to use number 3, which is your inverse. So the other thing you want to make sure that you're careful of is when you have a calculator, when you're using your calculator, your inequality must always be less than. And so if I say the probability that x is greater than k, you have to make that conversion so that your calculator gives you the right value. So how do we do that? Well, let's think about just the normal distribution curve. So if this is k, we see k is right here on this curve, and I tell you that the probability of being greater than k is p. So isn't the probability of being less than k going to be 1 minus p? Because that whole curve is 100%. So you're just subtracting that away so that you can find that value. So let's just practice one so that we understand how to do it in our calculator. So what I do is I draw it visually first so I understand what part I am finding. So I have a normally distributed problem with a mean of 23.6, a standard deviation of 3.1, and I want to find the probability of k or x being less than k is 95%. Well, 95% is going to fall over here somewhere. This shaded region is our 95%, and I want to find k. So what I'm saying is the inverse norm. I know my percentage, I need to find the k value. So you're going to go second vars, but now you're going to do inverse norm, which is number 3, and it's going to be your percentage, so 0.95, and then your mean, which is 23.6, and then your standard deviation, which is 3.1. And that's going to be, it's always going to be percent, mean, standard deviation. That's always how you're going to put it in. And so in this case, k is 28.7. So roughly 28.7 rounded 3 sig fig. Let's look at another problem. So a university professor determines that 80% of this year's history candidates will pass the final exam. So the examination results were approximately distributed, and the mean was 62, and the standard deviation was 12. So I'm already telling you that you are normally distributed with a mean of 62 and a standard deviation of 12. And it says find the lowest score necessary to pass the test. So I tell you 80% of the candidates are going to pass. So if we think about that normally distributed, here's our 62. If 80% is going to pass, this shaded region right here is 80%. So here is K. So that means that the probability of X being greater than K is 80%. But here is our problem. We're greater than, and remember our calculator cannot be greater than. We have to have a less than in order for our calculator to work, which means that isn't the probability of X being less than or equal to K going to be that other part, which is going to be 20%? Like, isn't this part 20%? And 20% plus 80% gives you your full 100%. And so now that we have that, we are going to do our inverse norm. So you're going to go inverse norm, and our percentage is 20. Our mean is 62, and our standard deviation is 12. And when we calculate that, we find, I'm going to come up here, K is 51.9. So that means that roughly 52, give or take 51, 52 people will pass the exam. Or excuse me, that's not right. The lowest score necessary to pass the exam. So 51.9 is going to be your lowest score in order for you to pass the exam. Sorry about that. Okay, let's look at one more problem. So I am giving you X is normally distributed with a mean of 40, and then we have 2.25. Now, if you guys remember when I first introduced this notation, I said you had to have a power of 2 on your standard deviation. Notice that 2.25 does not have a power of 2. So that's the first thing you have to fix. In order for me to get that into a power of 2, what is the square root of 2.25? Well, that means that X is normally distributed with a mean of 40, and if I take the square root of 2.25, I get 1.5. So technically that is what we have going on. And so it's saying find the score separating the top 7%. Okay, so if we look at that on a graph, here's 40. Isn't the top 7% going to be right here? Like this is 0.07%. So here's our K value. So again, the top 7 means that I am saying the probability of X that's greater than K is 0.07. So because I have greater than, I need to switch that to less than. So the probability of X being less than K is going to be, if I subtract that, I'm going to get 0.93. Because 0.93 and 0.07 gives you your full 100%. And so now because we have the percentage, we have to do our inverse norm. So you're going to go second bar is number 3 to get your inverse norm. Oops. And then we have our percentage of 0.93, our mean of 40, and our standard deviation of 1.5. Remember, we had to make that conversion here. That's very, very important there. You will have the wrong answer if you don't make that conversion. So K is roughly 42.2. So the score separating that top 10% or top 7% is a 42.2 on that exam or whatever this is talking about here. So that is how you find your K value.